Okay, we're on 2021 for Q number 2. So this is still a calculator portion, and I really truly encourage you to have your calculator and make sure you put some of these functions in your calculator so it eases your time in working on this, all right? Particle P is moving along the x-axis. The velocity of particle P at time is given by this function over here between 0 to pi at t equals 0. You start your position at 5. Okay, a second particle Q also moves along the x-axis. The velocity is given by this other function between 0 to pi at t equals 0. You start your position at x equals 10. So first thing I would recommend is you put this in as y1 and put this in as y2 because you know we're going to use this in a minute, okay? Find the positions of P and Q at time equals 1. So, you know, we have to take into account that you actually have some starting points. So for particle P, you started at 5 because that's your starting point. Then your velocity is given by this. So the total distance traveled after that is an integral between 0, because that's time equals 0, to 1, 0 to 1 of your function, your y1 function. So use your calculator to figure that out. For particle Q, similarly, you start at x equals 10, and you're still doing 0 to 1, but you have your second function, y sub 2, okay? All right, so since you are doing this all in the calculator, I'm going to leave you to finish this problem up at this point. Next, are the particles P and Q moving forward, toward each other, or away from each other at time equals 1? Explain your reasoning. So you want to look at your velocity, because your velocity, if your velocity gives you direction. If the velocity is positive, it's moving to the right. If the velocity is negative, it's moving to the left. So let's take a look at the first velocity, Vp of 1. So for particle P at time equals 1, what do you get? So you plug in 1 into your function here. You can use y1 and then use second calc and do value and just plug in 1. That's why I'm saying using your calculator is very helpful in this case, right? Plug in the 1, you get 0.841. Okay, and then plug it in for Q of 1, you get -1. So this one's moving right, this one's moving left. Okay, so then at t equals 1, you have, let's see, when you figure it out, oh, you actually have to get your answer here. So your answer is about 5.371 on the first, you have 8.564. So when you kind of graph this out, have an idea of it, right? This is 5. This is 8, so this is where particle P is, this is where particle Q is. Where particle P is moving to the right and particle Q is moving to the left. So they are moving towards each other and not away from each other. So you have to know their position at t equals 1, and then look at your velocity to see which direction they're heading at that moment, okay? Find the acceleration of particle Q at t equals 1. So again, this is where your calculator is really good. If you use math 8, it gives you the derivative at that point. So if you use math 8, it will say dx, you put in the x, right, of your function, so that's y2, evaluated at t equals 1. So that would give you your acceleration, and that will give you 1.0268. Very, very quick, right? So is the speed of a particle increasing or decreasing at t equals 1? So remember, speed is increasing if your velocity and your acceleration are the same sign. If they're both positive, they're working with each other. If they're both negative, they're still working with each other. It's when they're opposite sign, one is positive, one is negative, they're working against each other, then you're going to get speed is slowing down, speed is decreasing, okay? So let's see. Here we got the derivative, acceleration of Q is positive. So this is positive. So acceleration is positive. Now, how about at the velocity? So we have the velocity back up here. For Q equal for the particle Q at t equals 1, my velocity is negative. So velocity is negative. So remember, they're opposite signs, right? Because they're working against each other, therefore the speed is decreasing. Okay. Last but not least, find the total distance traveled with particle P over the time interval 0 to pi. So the key word is total distance. You want to make sure you get your negatives up. So there's a really quick way of doing that by putting absolute value about your velocity. Therefore, it's going to force all the stuff that's negative into positive. So since I'm looking for P, traveled by a particle P, that is my y1 function. So the total distance is equal to integral 0 to pi. Put absolute value around your y1 function into your calculator, and then put dt on that, or dx, sorry, not dt, because your calculator does dx. Then punch it in, you will get your total distance that way. Okay? All right.